good evening again, ladies and gentlemen, and welcome to another installment of Astronomy Toronto. My name is Randy Attwood, and I'm a member of the Toronto Centre of the Royal Astronomical Society of Canada. Astronomy Toronto is a news magazine where we look at topics of interest of amateur and professional astronomers, what they're up to here in Toronto, and astronomy across Canada. Tonight is during tonight's show, we'll be inviting you to phone us in to ask us any questions you may have on astronomical topics, whatever we might be talking about tonight, or anything you might have, any questions you might have to ask. On July 5th, Toronto will experience a very, very beautiful event up in the sky. That is a total eclipse of the moon. Now, this total eclipse lasts all night, the Monday night, July the 5th, and with me from the McLaughlin Planetarium is my good friend Ian McGregor, who is also the president of the Toronto Centre of the Royal Astronomical Society. He's brought along a few diagrams and slides to show us exactly how this eclipse will be occurring and exactly what we'll be able to see this July. So again, Ian, thank you for joining us on Astronomy.
Good evening, Randy. Glad to be here.
Well, I think, why don't we start with the moon itself, learn a bit about our nearest neighbor in the sky and the brightest object apart from the sun.
The moon is an object that I think we often take for granted when we're thinking about astronomy. It's an object which much of the month it's up in the sky. We can easily see it. After the sun, it's the brightest object that we can see in the sky. And perhaps it might be worthwhile just to kind of look at the moon and see what kind of an object this nearest neighbor to us in space is. First of all, it's the Earth's only natural satellite. We've got something of the order of about 4,000, 5,000 man-made objects that are orbiting around the Earth, but the moon is our only natural satellite that we know about. The moon is an object which is about a quarter the size of the Earth. It is orbiting around the Earth in a period of about roughly about 30 days, just about a month, and it's actually no accident that our word moon and the word month are very similar to each other. They both contain about 30 days. It's an object that if we look at a picture of the moon and study it closely, we can see that there are light-colored and dark-colored markings on the face of the moon. We have the dark areas, which are lunar seas. They got that name a long, long time ago, but of course we today know that the seas are just flat plains of basically frozen lava. Some people, when they've looked up in the moon at various times, have thought they could see a man in the moon, or a man's face, or a rabbit in the moon, or a lady in the moon. But these are basically flat lava plains on the moon.
Well, the full moon is a very beautiful object, and we have a slide of the full moon where we'll be able to see these dark areas. Now, the dark areas, the seas, they're lower, they're flat.
Yeah, they're very flat areas. These are basically where the astronauts landed. We have a photograph of the moon. The dark areas, again, are the lunar seas. We recognize about 17 of these seas on the near side of the Earth to us, near side of the moon to us. We have to realize the moon always keeps the same face towards the Earth. The light-colored areas that we see in the photograph are craters, or very heavily cratered areas, what we call the lunar highlands. And it was an area which the astronauts would have liked to land it in, but they didn't because it's a rather dangerous place to come down with spacecraft. Now, as far as our eclipse is concerned, it's perhaps important to realize that the moon is orbiting around the Earth. And during the course of a month, the lunar month, as the moon orbits around the Earth, it has a changing appearance in the sky. We could start off showing a picture of the moon, perhaps as a crescent moon, and then go right through a series of pictures showing these different phases of the moon. We go from, here we have a picture of a very young crescent moon, and perhaps as we very slowly go through these sequence of slides, we can go along to the next slide, and we'll start to see more and more detail of the moon as the moon goes around the Earth. When we cannot see the moon, that's the phase known as new moon. The moon is between the Earth and the sun. But as we continue to go from slide to slide, we can see more and more of the moon. We're going through a waxing crescent moon. There we are, first quarter moon. That's roughly what the moon is like tonight. We're now going into a waxing gibbous moon, and very soon we're going to be getting to a full moon. Getting very, very close to that now. When we have a full moon, the sun, the Earth, and the moon are in a line. And of course, when we look at the moon like this, we're seeing the moon by reflected sunlight. It's not the moon that's actually giving off its own light. It's light from the sun that we're seeing. And then after we have the full moon, we keep on going along through this. We can see the other phases. This is a waning gibbous moon. We get around to what we call last quarter moon. We still see these same, there's the last quarter moon. We can see these dark seas that are still present. And continue to go along, we find we're now into a waning crescent moon. And again, it takes roughly about a month to go through all these phases. We get along to a very, very thin crescent. And then I think we have one more slide. That's it, and that's our waning crescent. And after this, we go again to a new moon phase when the moon is again between the Earth and the Sun, and we cannot see it. Now, to understand perhaps what is happening as far as lunar eclipses are concerned, and this is our particular topic of event as far as July 5th and 6th are concerned, we had to realize that between, at various times, you have lineups between the Earth and between the Sun, the Moon, and the Earth. We might come along and consider the fact that if we have the orbit of the Earth, if the Moon was in the same orbit as the Earth's orbit, this would mean that we would end up having eclipses every time the Moon moved in front of the Sun and every time the Moon moved through the Earth's shadow.
So every month there would be two eclipses?
We'd have two eclipses every month. A solar eclipse when the Moon is between the Earth and the Sun, and a lunar eclipse when the Earth is between the Moon and the Sun. However, this is not the case, and the reason this occurs is because the Moon's orbit is tilted at an angle of 5 degrees with respect to the plane of the Earth's orbit, as we can see in this diagram. And this tilt is sufficient to make it mean that we do not have that many eclipses. We have perhaps a maximum of 7 eclipses that might occur in a year, solar or lunar. I think perhaps we could look at perhaps a picture of the slide of a solar eclipse. A solar eclipse occurs when the Moon is between the Earth and the Sun. There are several different kinds of solar eclipse, and what we're showing a picture of is the most spectacular kind of a solar eclipse, a total solar eclipse. Although the Moon is about 400 times smaller than the Sun, it is also about 400 times closer to us than the Sun. And the result is that these two objects, the Sun and the Moon, have the same apparent size in the sky, about half a degree. That's about half a finger width. If we came along and took our finger, held it at arm's length, about half a finger width, about half a degree. Well, we have these spectacular total solar eclipses that can occur. You know, we've both experienced several of these eclipses in our solar eclipse expeditions we've gone on.
But you have to go usually somewhere to see a total eclipse of the Sun. We had to go to Africa to get that picture.
There's just a very narrow part of the Earth which you can actually see a total eclipse of the Sun from.
But it's very different with a lunar eclipse.
Lunar eclipse is quite different. On one hand, a solar eclipse can be very fast. It only lasts a few minutes, and then the spectacular part is gone, as we saw on that slide that we saw of the total solar eclipse. A lunar eclipse, though, takes place over a much longer period of time. This lunar eclipse is taking place in July, for example, is going to be taking place over just a little over 6 hours from the beginning of the eclipse until the end. And even at maximum totality, when the Moon is going to be immersed in the Earth's shadow, it still takes a while for the Moon to pass through that. I think perhaps we have a diagram which perhaps illustrates that. No, it's going to slide, I guess it is. This is just showing the geometry of the Earth, Moon, and Sun. In this, we have on the right, we have the Sun. Sitting roughly about the middle, we have the Earth. And the light from the Sun is hits the Earth and produces a shadow, sort of in the tail of the Earth. And this produces a long shadow. The Earth's shadow extends out to a distance about 3 times greater than the Moon's distance from the Earth. And this shadow is fairly large. In fact, at the Moon's distance from the Earth, the diameter of the Earth's shadow, as we can see in this diagram that we have here, the diameter of the shadow of the Earth, it has actually 2 components to it, an umbra and a penumbra. The diameter of the umbra, which is the dark central region of the eclipse, is about the same diameter as that of the Earth, about 12,000 kilometers. On the other hand, our poor little Moon is only about 4,000 kilometers in diameter, and it takes a while for it to move through this very dark central region of the shadow.
Well, it's difficult to remember that the Moon, as the Moon travels across the sky from east to west as the Earth turns, the Moon travels its own distance from west to east And that's why it takes so long for the eclipse to happen. The moon is slowly moving through. I think we have another diagram later on which shows that.
I think we do, yeah. This basically is showing our shadow conditions. The dark region, the umbra, when the moon is into that, we have a total eclipse. The umbra is something which we don't really see very well. It's kind of a half shadow region around the Earth, around that area of the sky. Now, I think perhaps we have another diagram that we could show, which might help to explain a little bit about this. Again, I mentioned we don't have an eclipse every time the moon is at the full moon phase. A full moon is the only time that you can have a total lunar eclipse occurring. And in this diagram, it's showing us the fact that the orbit of the moon is again inclined about 5 degrees to that of the Earth. It means, for example, that the moon can pass high above the Earth's shadow. We could have, first of all, the moon just passing through the penumbra, or the half-shadow region. And we have this in the bottom part of our diagram. The moon might get just slightly darker, but it's very hard to spot a penumbral eclipse. It's not really that obvious an event that's taking place. We can also have what we call a partial eclipse of the moon. This is when the moon, going along, passes through the Earth's shadow. It does not get completely immersed in the umbra region, but part of it is still out in the penumbra, and as a result we only have a small part of the moon which sort of disappears into a dark shadow fall across it. In the case of this particular year, we've got 3 total lunar eclipses taking place. And again, in our diagram, we have the moon would be coming along on its path, and it passes through the actual umbra, and it goes right through the very darkest region of the Earth's shadow, and as a result, we have a total lunar eclipse.
I like to think, too, Ian, that for when the moon is passing above, if you were standing on the moon, you would see the Earth pass by the sun. For a penumbral, say, you'd see the Earth just take a bite of the sun, so that you'd still be able to see part of the sun. But it's only for a total eclipse of the moon, when you're standing on the moon, you see the Earth totally cover up the sun, which I'm sure would be a beautiful sight.
Spectacular sight, I'm sure, if we were an astronaut on the surface of the moon looking out at this sight taking place.
Well, they actually have photographs from an unmanned spacecraft which was on the moon. It looked up at the Earth and took pictures in 1966 of that site. I guess it's never really been seen before by human eyes, though.
Is that the lunar eclipse that is taking place is going to be a very dark central one. We've not had this dark eclipse for a number of years. Sometimes when the moon passes through the umbra of the Earth, the dark inner shadow, it does not pass right through the center, and the eclipse may not be that dark. But this one, it's going to go very, very close to the central regions. We'll have a diagram later on to talk about that. But it's going to be quite an eclipse to see. It might be worthwhile just to get some idea of the frequency of eclipses, and we have a diagram that shows that, a table that shows the eclipses that have taken place over the last number of years. Usually we get no more than the maximum is possible. A number of eclipses that can occur in a year is 7. We do not, this happens to be a year when we are getting 7 eclipses. These can be a combination of lunar or solar eclipses that we can get. Usually we get no more than maybe 3 or 4 solar eclipses that can occur. 72, I think, was an example of a year when we had 7 total eclipses 7 eclipses that occurred, a combination of lunar and solar.
And that's the maximum. You can't have
That's
more
the
than
maximum
7.
possible that can occur. This year we have 7, so that's, I guess, twice within a 10-year period we've had the maximum number of eclipses. If that's taking place, this means there must be an eclipse taking place very near the beginning of the year. In fact, we have one this year on January 9th, and then we have another total lunar eclipse occurring right at the very end of the year on December 30th. But the best one for North American observers, in fact the best one for us to look at, is the one that's taking place in July.
We have another table which we'll be able to look at the last 6 years of lunar eclipses, which shows that there are actually eclipse seasons. In the year 1982, you can't have an eclipse in March. You've got to have an eclipse in, well, I guess this is actually the July 5th eclipse. Maybe if we get that other table up showing the other eclipses, you cannot have an eclipse in, say, 1982 in March. This year happens to be July and January for seasons. We see in 1977 that there were eclipses. The eclipse months were April and September. And these were lunar eclipses, which we could see both of, one in April and one in September. And in 1978, of course, you have March and September, and it goes on like that. And these dates change slowly. About every 9 years, it rotates so that you have eclipses in different parts of the month.
That's right. Last year, for example, we had a partial eclipse of the moon that occurred in July, and this year it's working around to this year. We're having a total lunar eclipse taking place in July. And next year, in fact, there's going to be another eclipse that's occurring near the tail end of June. So these are all coming relatively close together.
Well, we have a diagram here, Ian, of the eclipse. Maybe we get on to the one that we're all looking forward to, weather permitting.
Oh, it's going to be clear without any doubt at all.
Certainly hope so. It'll be nice and clear. This is more or less the track of the moon through the Earth's shadow as we'll see it in the early mornings of July 6th.
In the early morning of July 6th. I should point out that for Toronto observers, the eclipse is starting about 22 minutes after midnight on the morning of the 6th. In this diagram, we again have the Earth's inner shadow, the umbra, and then this dashed area is showing us the penumbra. We have the moon moving across from the right and going over towards the left. And then roughly at about 22 minutes after midnight on the morning of July 6th, the first contact takes place, and then we start to have the moon enter the Earth's outer shadow, the penumbra. Roughly at about 1:30, we have the moon start to enter the umbra. And at this point, it starts to get very noticeable that there's this shadow, this kind of wave of darkness that's gradually moving across the moon from left to right. We then go to continue throughout the eclipse, and then about in the wee hours of the morning, about 3:30, the moon is right in the middle of the umbra of the Earth. And at that point, we have the darkest part of the eclipse, and the moon may almost appear to disappear at that time. About 5:29, the moon will leave the umbra, and then around 6:40, the eclipse will end. The moon will leave the Earth's outer shadow, or penumbra. We're not going to be able to see all of that eclipse. Unfortunately, the moon will be setting in the western sky before the eclipse is actually ended.
I think for anyone at home that might want to copy down those numbers, we have a table, and if we could get that up, you'll see that it's a long eclipse. It lasts, the time, the duration is over 6 hours.
Yeah, 6 hours, 17 minutes. And it's worthwhile to look at. The mid-eclipse, admittedly, it's a rather strange time of the morning. People are going to have to stay up pretty well all night in order to get the very best part of the eclipse. But it certainly can be a very spectacular sight to see. It's certainly not like a total solar eclipse. A total solar, you've got 2 or 3 minutes and you're enjoying this fantastic event that's taking place in the sky during the daytime. Total lunar eclipse is a relatively slow-moving kind of an eclipse.
I intend to get out my lawn chair with maybe a bottle of wine and maybe some music or something and just enjoy it.
Just relax.
It's really
going to
be a super sight too, weather permitting, of course. We have some slides of previous eclipses, including the one that was last summer, which we saw here in Toronto. We can take a look at that and maybe give you a preview of what this eclipse is going to look like. This is last July's eclipse. Now the moon, Ian, passed just north, just above the umbra.
Just above the umbra.
And maybe we can go to the
next. These are your own pictures too.
Yeah,
so
well,
I'm pointing at too.
Sure. Even I can take pictures of the moon. In the next, in the next slide, we'll see that it's a bit overexposed, but you can see that the light, the darker part at the bottom, is the umbra, and you see it's a reddish color, which is a fascinating aspect of a total lunar eclipse.
At this point too is also about as far as the moon was covered in darkness at this point. This is about mid-eclipse, this partial eclipse that we experienced.
And also, which is a historical note, this is one of the first ways they were able to distinguish that the Earth was round. Because way back when, I'm not sure who was the first one to discover that, but looking at the Earth's shadow on the moon, it appeared round, and they were able to even figure out the distance to the moon by that method.
That's right. It's an experiment, actually, people can try at home. If you have a bright light and shine it onto a wall, and you try different geometrical shapes, triangles, squares, boxes, whatever it happens to be, and look at the shadows that they make. And the one that turns out best is one that has a sphere.
Well, maybe in the next couple slides we can see the progression of that eclipse. Here we see the moon moving out. This eclipse took a few hours. The moon slowly moved from right to left, as it passed through the shadow, and I think in the next one it's just about moved all the way out. Now that was a partial eclipse. In the next couple slides we have pictures of a total lunar eclipse, and what you might be very surprised to see is that the moon gets very, very red, copperish color. I remember the eclipse in 1975, though, was a dark eclipse, and that varies from eclipse to eclipse.
It can vary quite a bit depending upon the amount of dust and volcanic dust that's in the atmosphere. This eclipse might be very dark. Perhaps you might explain why it's red. First of all, the moon is in the Earth's shadow, and hence there's no light. We'd think there's no light from the sun, which would be falling onto the moon, so hence it would be dark, we can't see it. But actually what is happening is light from the sun is passing through the Earth's atmosphere, and then it's being bent. And the light that manages to get through the Earth's atmosphere is the red light. And that red light falls on the moon and bathes it in a kind of a reddish glow. And depending upon the amount of dust or stuff that's in the atmosphere at the time, particularly volcanic dust from active volcanoes or something like that, we can make the moon very, very red. Sometimes, for example, the moon can be almost a blood red color in the moon and in the sky, a very, very spectacular sight. And I'm not surprised that many ancient people were very concerned when they would see these eclipses taking place and the moon being blocked off, parts that seem to be disappearing, and then maybe getting this very noticeable red color in the sky.
Well, as I say, if you have any questions you might want to ask Ian about the eclipse or anything else of an astronomical nature, why don't you give us a call at 752-8911, and we'd be pleased to help you out to answer these questions which you might have. There are several other things that you can do when you're watching an eclipse. And there is we were talking about the brightness. You can measure the brightness scale. We have one member in the Toronto Center of the Astronomical Society who draws the eclipse. You don't necessarily have to photograph them. And film isn't that sensitive. The eye picks up so many different colors.
A lot more detail.
That
more detail with the eye.
The drawings really give you a better appreciation of the eclipse itself.
That's right. It's possible you can make a drawing using your eyes alone, just kind of noticing the color that's taking place in the changes in the moon. You could go ahead and use a pair of binoculars. Ideally, you should have set up on a tripod, so you're not kind of looking through your binoculars and then putting them down and then making your sketch or adding on colors, or looking through a telescope, for example, and noticing the different color changes. It is quite remarkable. The colors are not uniform. They can be browns and yellows and reds, and but perhaps particularly red might be
green too. I was amazed. Last year we saw green.
That's right. I guess we did see green anyway.
Hello, welcome, and thanks for phoning Astronomy Toronto.
Well, thank you very much. Do I have to turn my TV off?
No, it's no problem.
Okay.
What can we do for you?
Well, first of all, I really enjoy this program. I'm just getting into astronomy, and I just want to tell you that. But secondly, where is the best place to see this? Can we see this from Toronto? I mean, the lights in the city and everything. We can't see very many stars at night, and I'm just wondering whether we can see the eclipse from Toronto.
Okay, well, first of all, the moon is an extremely brilliant object, and we'll have no trouble seeing it. We may end up having a full moon means we wipe out all the stars, but we'll have no trouble seeing the moon, barring the presence of clouds or something like that. It might be worthwhile also to mention about visibility of where can you see this eclipse. This eclipse is visible almost over the entire Western Hemisphere. South America, Central America, North America, except for some of the northern regions of Canada, we'll be able to see this total lunar eclipse. A total lunar eclipse is visible from the entire hemisphere of the Earth.
As long as you can see the moon.
As long as you can see the moon.
You can see the eclipse.
That's right.
But it's very different for a solar. You have to be right underneath the very small leading edge of the shadow.
You've got to be in a narrow region that might be about 100 kilometers wide and about 3,000 kilometers long. And unless you're in that very narrow path, you cannot see a total solar eclipse. But a lunar eclipse is visible all over the Western Hemisphere. We'll be able to see it.
Okay, can I ask a couple of more questions?
Yeah, give us another question.
Well, okay. First of all, what groups are there groups you can get into in order to start from, I guess, as a beginner to get into astronomy? And then there are a couple of questions, but I don't have to pursue them with regard to what you've already said.
Yeah, this is the person to talk to. Ian is the president of the Toronto Center of the Royal Astronomical Society, and we have a very large contingent in Toronto, don't we, Ian?
Well, our Toronto Center is one of actually 20 centers or clubs of the Society across Canada. Our society has about 3,300 members, and there are over 700 in the Toronto Centre. We hold our meetings at the McLaughlin Planetarium, and the members of the society are all different ages. I guess I know our youngest members might be about 10 years old. Our oldest might be as old as I possibly think. I don't know.
As old as you.
Well, maybe as old as me. That's right. But they come in all different ages. They can have all different backgrounds. There are professional astronomers. There's amateur astronomers. People of all different educational backgrounds. We hold meetings which have professional astronomers or scientists who give talks on different aspects of astronomy or space science. We have observers meetings when members of the center give reports on their observations, talk about constellation of the month, talk about telescopes that they built, or how to, pictures of the sky as seen from Toronto, or what you can see, or astrophotography tips, or things like that, all different kinds of things. So belonging to an amateur group gives you access to other people who are interested in astronomy, and you can kind of learn from there. You might also be interested in taking astronomy courses as well, like an introductory course in astronomy. The planetarium offers a series of courses during the autumn, winter, and the spring, and you might be interested in contacting the planetarium and perhaps taking one of our astronomy courses. There are several other institutions, York University, University of Toronto, Seneca College, I think, also have courses in astronomy.
Again, the lunar eclipse is July 5th, 6th. Hope you do get a chance to maybe set your alarm at 3:30 and run out in your pajamas and take a quick look, or even if you want to brave the weather, you can get out and take a look at it. I'd like to thank Ian McGregor from the McLaughlin Planetarium for coming out and for being much of a part of this series.
Thanks for inviting me, Randy.
Toronto. And again, at the end of the show, on the credits, we will be displaying the address that you can write to if you're interested in finding out more about the Toronto Centre of the Royal Astronomical Society of Canada. Again, it's a group of amateur and professional astronomers, more or less interested in learning more about the sky, getting out and enjoying the sky from Toronto, and especially out away from the Toronto city lights. So thanks very much for watching Astronomy Toronto, and we'll be seeing you again real soon.